Hey everybody, it's Jeff, and here's what I did over the past few days for Workbench, where I stream my open source innovation work on Twitch. So, continuing on my tree view prototype, I've been experimenting with the actual data model of the nodes behind the tree view. So previously we had a tree view, and then it was sort of modeling the tree nodes in Go like this, and then we would load them into JavaScript into a data structure that could be used in JavaScript. But I guess ultimately this node is a representation of a more complex node in the system that I'm actually building, right? It's a sort of like hierarchy of, like Unity, hierarchy of nodes that have components on them, which is a little bit more complicated than the model that we have here to visualize it. So we had to model the more complex node, which also has its own tree structure and API to manage that structure, insert stuff. So I started that here, and it has basically an API that does a lot of what we did before on our tree nodes, but in an API that's sort of specific to this model, and added some other stuff like being able to find a node by ID or by name, and then we actually return a representation of a tree node that we then use to generate this tree view. But this gives us a lot of flexibility in sort of like the API of that data model and stuff like that. I also had to make sure that this was a serializable data structure, and this led to a few iterations. What I have now is really simple, but I almost had a separate struct to model the data as it would be serialized. But then I'd have kind of almost three representations. I'd have the tree node representation, this node representation, and then how this node is stored on disk when serialized. And it was mostly because I was like doing some of these fields as private things, because I'd have getters and setters for them, and I was like, well, that's not really necessary, and it just ended up being so much easier to just do it this way and serialize this struct directly. The other part of this, though, is the components. So a node has a bunch of components on it, and a component is really just an arbitrary struct. So it has some struct values associated with it. The possible values are first registered in this registry. So our one example here is demo component, and we register that component, and so now we can add that struct to any node, and part of this was getting them to serialize correctly. So you might have saw that we have this component set struct, which will eventually have a registry thing that I won't get into now, but this component set also has its own, because it's a list, so it has remove, add, insert, append, basically working on a slice of components. And again, these are just arbitrary structs. However, we have to have some metadata about them in order to serialize them and unserialize or unmarshal them into the proper data type. So we wrap it with, originally it was just component, but because of some trickiness that I'll explain, we wrap it in component data, which is a representation of component. This is the first time I had to use marshal JSON and unmarshal. So marshal JSON for a component basically gives us something that looks a lot like component data. And in fact, I could use component data probably, and I marshal that. And so this basically gives us, it's going to try and marshal whatever this component is referencing into a field called data. And then when we unmarshal, we unmarshal into this component data struct. And this was necessary because you get into an unmarshal loop if you try to do this directly on the same. Like I tried to have data in here with ref, but that didn't work. So I have this unexported struct that's used for mostly for unmarshaling, and it uses a raw message, which actually defers unmarshaling a particular field, so that we can kind of do a partial unmarshal, get the name, and we already have this sort of component factory. And so we can put that in and get an instance of our component by whatever name that it was stored, and then unmarshal the rest of the data into that component instance, and then set that to ref. So anyway, little tricky, took some experimentation. Then I was ready to recreate the property inspector that the original prototype had, but I wanted to recreate this with the UI components instead of wrapping that jQuery library from before. So this way I actually dogfood the UI framework that I've been working on. And I ran into a few issues. So here's an example. I'm using a little bit of styling of the semantic UI toolkit. And I actually have components for all of these. So I guess going top down now, we have this new floating div that has an inspector in it, and we get a reference to it because we use that to handle when you click on one of these, we change the node that the inspector points to. And inspector isn't that interesting of code behind it, but here's the template. So a couple of things that we had to figure out here. First of all, the if directive wasn't working super well, so I had to tweak that to make sure that it's not just handling Boolean values. We can say, because we have a reference to a node here, and if that's a nil reference, right, that should evaluate to false. The other thing that you might notice here is, for some reason, if this does evaluate to false, then that basically gives us a nil template, and we error on that. So for the time being, I can't actually put something like an if directive on the outer element, and we always need the outer element as well for now. So just kind of a tricky thing here. Then we have these property sets, which are basically this whole little accordion thing here. And the first one is of the node, and then we do a loop to show one for every component that we have, specifically the ref value that it has. So here's one that has a ref. We're looking at so one here doesn't, but we can add a component. I also got this context menu working again. So we add that. We have to go and redraw it, but now so one has a demo component. And so now let's look into property set. So property set is pretty simple. It takes a value as a property, and the first time I kind of had to run into this pattern so far with this framework. So we do reflection of the value to be able to figure out what the name and fields are. And this might be considered like a computed field or something in like a view or in Vue.js or something, but basically we're just, every time we render, we set these fields that the template's going to use. Property set here, we've got our name, and then we have a property field that is, at the moment, it just has a name property that we get from the field. So our fields is actually just giving us a list of the fields that it has, and then we can go into property field, which is right now just has a name and value property, and is basically one row here. So we have a label that has a name, and then right now it's hard coded to a text input. But you can see how we're getting pretty close to, it's already listing the fields on a particular struct value that we give it. We just have to add some like struct tag stuff to be able to say hide certain fields or whatever, and then start doing some type switching and start showing a different value representation here, and then when you change that, it changes the value. But it's coming together. Yeah, like I said, I ran into some issues, found some workarounds, fixed other issues. But yeah, so it's exciting to be able to use this WASM UI framework, and things mostly just work. And so that's it for now. Let me know if you have thoughts or questions in the comments. Subscribe if you'd like to start following along, or join me on Twitch Tuesdays and Thursdays when I work on this stuff, as well as any other time I feel like working on. But my regular time is Thursdays and Tuesdays. So thanks for watching.